Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Welcome to the course of Theory of Automata, CS311. It's lecture number 20, and today we will discuss about Chomsky's normal form. So let's discuss today's agenda. Today we'll discuss about Chomsky's normal form, and then we will see the context-sensitive grammar and language. So let's just discuss about Chomsky's normal form. First, we should know what is a normal form before Chomsky's normal form. In context-free grammar, the left-hand side of production rules contains only one variable, and the right-hand side may contain any number of variables or terminals in production rule. In the previous lecture, we have studied about the context-free grammar, in which we have studied different terminologies like terminals and non-terminals and the production rules. And according to that lecture, you have the knowledge of the production rules, because there are some non-terminals such as a, and it implies that a implies that alpha. This means whenever we encounter a in our substrings, we replace that a with this terminal which is called an alpha. So this is a production rule in context-free grammar. We have studied this concept before, in which the production rule has only one non-terminal on the left-hand side. This is called the left-hand side, and this is called the right-hand side. Okay, this is the right-hand side of the production rule. So in production, the production rule states that on the left-hand side there is always a non-terminal, and on the right-hand side there are always a combination of terminal and non-terminals. So this is the basic concept we have studied. The production rules in context-free grammars are in the form such that a, where a is the variable, and a is a string of end symbols from this subset which is called v union t, and the inclusion of this. So if you want to impose a restriction on the right hand side of production rule, then context-free grammar is said to be a normal form. So this is the key point. Let me highlight this. If you want to impose a restriction on the right hand side of the production rule, then the context-free grammar is said to be a normal form. So what that restriction is, do you have any idea? So let's move on and see what is that restriction is on the rule. Okay, in Chomsky's normal form, there are restrictions on the length of right hand side. So first remember or try to understand this concept that the rule is on the right hand side, and the type of symbols is used in right hand side of the production rules. So this is the second requirement, which is with the help of which we convert any context-free grammar in Chomsky's normal form. So the first restriction is on the length of the right hand side. So this is the left hand side, this is the left hand side, and this is the right hand side. So the first rule or restriction is the length on the right hand side, and the type of the symbols is used in right hand side of the production rule. What are those symbols which are used on the right hand side? These two restrictions are imposed in Chomsky's normal form. In this you can see that a, b and c are variables. A, b and c are the variables, and a is a terminal. Note about Chomsky's normal form: every grammar in Chomsky's normal form is context free. This is the advantage of Chomsky's normal form, that any grammar which is in Chomsky's normal form is also a context-free grammar, and conversely, every context-free grammar can be transformed into an equivalent means Chomsky's normal form on one which is in Chomsky's normal form. So context-free grammars are converted into Chomsky's normal form, and Chomsky's normal form grammars are also called context-free. And it has a size no larger than the square of the original grammar size. So this is also a very key point regarding the size of the grammar. What is Chomsky's normal form? A context-free grammar, as we studied before, that a context-free grammar is in we can convert a CFG into Chomsky's normal form, and say Chomsky's normal form is also a context-free grammar. So a context-free grammar is in CNF, Chomsky's normal form, if all production rules satisfy one of the following conditions. This means that we need to ensure that some production rules that the production rules must satisfy either one of the following conditions. It doesn't mean that all, but at least one rule should be satisfied. The first rule is start symbol generating epsilon. For example, A implies that epsilon. This means that we can substitute A as an epsilon. We can replace A with epsilon in the substrings. This is allowed. And a non-terminals generating two non-terminals, for example, S is a non-terminal because it appears on the left hand side, and it is generating two non-terminals. Okay, so this is also a condition that needs to be fulfilled if you want to transform a context-free grammar in a Chomsky's normal form. This is the second condition in which S is a non-terminal and AB is also a non-terminal, but what is that length restriction? A and B are also non-terminals, but the length of this must be 2. Okay, and third condition is a non-terminal generating a terminal. For example, S is generating a non-terminal, generating a terminal which is A. Okay, so these are the conditions with the help of which we can convert any CFG into CNF. Remember that the first condition, it has a start symbol, and that start symbol is generating epsilon. Epsilon means null string. Okay, and the second point is a non-terminal. Here you can see that S is a non-terminal because it appears on the left hand side, but it is generating two non-terminals, which is A and B. And the third condition is a non-terminal is generating a terminal. Here S is a non-terminal and A is a terminal. Where A, B, C are non-terminal symbols, A, B, and C are non-terminal symbols. Remember this point that A, B, and C are non-terminal symbols, and the letter A is a terminal symbol, a symbol that represents a constant value. So a terminal symbol is always a symbol that contains a constant value. So this is a very key point. You should remember this in your further numericals or questions. You can differentiate terminal from non-terminal in a sense that a terminal symbol is a constant in its whole life, and S is the start symbol, and E denotes the empty string. So these are the rules of Chomsky's normal form. Try to remember these rules, and you can convert any context-free grammar in its CNF. The first rule states that S is start symbol generating epsilon. This is the first rule. The second rule states that this is a length. Let me write this so it can be remembered later on. Length restriction. Okay, this is a length restriction. Length restriction. Okay, a non-terminal generating two non-terminals, and a non-terminal generating a terminal symbol, and this is the explanation of the above three concepts. Examples. Here you can see this is the grammar 1 and this is the grammar 2. As you can see that S is a non-terminal and it is generating two non-terminals. Okay, here you can see S is a non-terminal and it is generating a terminal. Here you can see that A is also generating a terminal, and this means that a non-terminal where B is a non-terminal and it is generating a terminal symbol. Similarly, in grammar 2, S is a non-terminal and it is a combination of a terminal and a non-terminal. A non-terminal symbol is generating a terminal and a non-terminal generating a terminal, which is called B and C. So the production rules of grammar G1 satisfy the rules specified for CNF. So the grammar G1 is in Chomsky's normal form. As you can see, we have to check only one rule above three rules, because in this grammar you can see that it is satisfying two conditions. The first condition is a length of 2. A non-terminal symbol is generating two non-terminals. The restriction length restriction is completed over here. Similarly, a non-terminal symbol is ending on a non-terminal on a terminal symbol. S is a non-terminal and C is a terminal. So a non-terminal symbol string is ending in a terminal. Similarly, a non-terminal A is a non-terminal and it is ending in a terminal. Okay. Similarly, B is a non-terminal and it is ending in a terminal. So we can we can impose that the first grammar is in Chomsky's normal form. However, the production rule of grammar G2 does not satisfy the rules specified for CNF, as S implies that AZ contains terminals followed by non-terminal. So that's why we have rejected grammar 2 and it is not in a Chomsky's normal form. So this is the main difference between a Chomsky's normal form and other grammars, in which the Chomsky's normal form has some rules that needs to be followed, that needs to be completed before converting that grammar in a Chomsky's normal form. What are the steps that needs to be taken to convert a context-free grammar to a Chomsky's normal form? The first rule says that if start variable s occurs on the right hand side of any production rule, then create a new start symbol s dash and add as a new production rule such that is s dash implies s in given production rule. So this is the first point in which we are converting any context-free grammar into CNF. It states that if start symbol or variable s occurs on the right hand side of any production rule, then we will create a new start symbol, which is let's say it's s dash, and add as a new production rule s dash implies s. Remove or eliminate all null productions. So try to remember this point, that we have to remove all null productions. Let me erase this and okay, and let me use this. Okay, yellow. Remove or eliminate all null productions in a given production rules. The first this is the second point, that we have to remove all null productions in a production rule. And after that we will have to remove or eliminate all unit productions in a given production rules. So this is also a very key point. We have to remove null productions or unit productions in a production rule. So these are the steps with the help of which we can convert context-free grammar to a Chomsky's normal form. But remember these points, that if start symbol occurs on the right hand side, for that we will introduce a new start symbol s dash, and after that we will creating this new rule. And the second point states that we have to remove null productions, and the third rule states that we have to remove unit productions. In this step, find out the productions which have more than 2 variables in right hand side. So we need to take care of this, that we have to find out the productions which have more than 2 variables, and repeat this step for all productions having 2 or more symbols in the right hand side, and so on. Okay. If the right side of n production is of form A implies AB, where A is a terminal symbol and A and B are non-terminals, then the production is replaced by A implies that XB, and where X is equal to A, because this is against the Chomsky's normal form, because this rule states that non-terminal is ending in terminal with a non-terminal. So first we have to remove this non-terminal, this terminal from this place, and we'll create a new rule which is called X implies A, and we have used this X over here. Here you can see we have the length restriction as well, 2 non-terminals, non-terminal ending in 2 non-terminals. So this is the way with which we convert any CFG to CNF. So let's see some examples of Chomsky's normal form. This is example number 1. First we have to convert the context-free grammar into Chomsky's normal form, and these are the production rules. Okay, these are the production, let me write, these are the production rules. This is a context-free production rules. These are the production rules. So our task is to convert this context-free grammar to a Chomsky's normal form, and these are all the production rules. Here you can see that S is a non-terminal, and it is ending in 3 non-terminals, AA and ASA. Similarly, S implies that A and B, this A is a terminal and B is a non-terminal, non-terminal and non-terminal, and here non-terminal, non-terminal, non-terminal ending in epsilon null string, and non-terminal ending in terminal, and non-terminal ending in null string. So what is the first step in Chomsky's normal form? As we can see that S is the start symbol or a start variable. As S variable appears on the right hand side, then we can add a new start symbol as dash and add a new production rule as dash as, because we can see that S appears on the right hand side. So first of all we should eliminate this and create a new rule such that S dash equal to S, and after that the same transactions appear on the right hand side as well. So this is our original production rule. These are the original production rules, and after step number 1, because the S symbol is appearing over here as this is also highlighted, so for this step we have to create a new rule, which is S dash equals implies that S. The second rule states that we have to remove all the null productions, that is A implies epsilon and B implies epsilon. So as you can see that we have removed this one and this one. So this is the second step in which we have removed all those null productions. Null productions have been removed. Okay, and after that we will retain the first rule and this one. Okay, and S is equal to B and this one and this one and this one. The third, remove the null productions. We have removed the epsilon productions, but we have also seen that after doing this step the remaining substrings are as follows. After that, the third step is remove unit productions. What are the unit productions? This is a unit production. We have removed this one, this one. These are all the unit productions. Okay, we have to remove these things as well, this thing as well, because we are ending in two non-terminals. We are ending in one terminal is ending on another terminal. That's why we called it unit productions. So we have to remove these strings as well, and after that we can be, here you can see that this is the same string, and this is also a same string. S is a non-terminal and A is a terminal, so it's okay, and S is equal to AS and S is equal to SA, and we have removed this, so no need to, and this one and this one. So rest of the strings are as it will follow as it is. After removing the unit productions, A implies B, two non-terminals, one is on the left hand side and the second one is on the right hand side. The new production rule is S dash ASA, AB, AS and SA. Okay, same rule. So these are the production rules, and where A, we can replace A with B or S, and we can replace B with B in the above production rules. So this is the solution of example number 1. Our CFG is converted into CNF. This is the uh, uh, final rule that needs to be taken on. After remove the unit productions, AS, then production rule is this one. Okay, simple, very simple. No need to be. I hope you have understood this concept very well, and so on. Step number 4. Now find out the productions that has more than 2 variables in right hand side. S, A, more than 2 variables. These are the rules that they have more than 2 variables. ASA, 3 variables and 3 variables. After removing this production, the new production we get this. Here you can see 2 production, 2 non-terminals on each. So we have to remove all these things. And then we have to change the productions. S implies A, B, and S is equal to S implies A, B. Both rules are simple, and A implies AB. Finally, we can get the production after converting the given context grammar, free grammar to Chomsky's normal form. So this is a non-terminal, and these are all this is also a non-terminal. This is also a non-terminal. This is a terminal and a non-terminal, and this is, we can select either one of them is a terminal and non-terminal and non-terminal, and we can replace this S with these for 6 components, 1, 2, 3, 4, 5, and 6. Okay, we can replace this S with either one of these, and similarly we can replace A with one of these. Okay, and as you can see that we have B's as well, so we can replace B's with small b, and we can replace this X non-terminal with SA. Here you can see this is also a non-terminal as an A, and here you can see that we can also replace this non-terminal with YA. Okay, so we have multiple options and multiple non-terminals, although it looks very complex, but doing some practice and hands-on, you all will be very comfortable with this notion. It is also very interesting when we are practicing those numericals. So we have different options with the help of which we can generate different strings. As you can see that we have different non-terminals on the right hand side, and we are replacing those non-terminals with their respective substitutes or replacements. We call these as our replacement. Okay, these are all the replacements. So this is the required context normal form for the context free grammar. So let's discuss another topic which is called a context sensitive grammar, pronounced as CSG. A context sensitive grammar is an unrestricted grammar. This means that we, like in context Chomsky's form, we have seen that we have imposed some restrictions on the right hand side, but in this case which is called context sensitive grammar, we have not any such restrictions. That's why we called it unrestricted grammar, in which all the productions rules are of form alpha implies beta, where alpha and beta belongs to this clean closure, and absolute value of alpha is less than equal to absolute value of beta, where alpha and beta are strings of non-terminals and terminals. So like in context free grammar and in Chomsky's normal form, we have seen that the left hand side is also always a non-terminal, but in this case this is a terminal or a non-terminal as well. They are alpha and beta can be a non-terminal or a terminal at the same time. Context sensitive grammars are more powerful than context free grammars. Why? We are seeing this, that the context sensitive grammars are more powerful than context free grammars, because there are some languages that can be described by context sensitive grammar but not by context free grammars, and context sensitive languages are less powerful than unrestricted grammar. So this is the main difference between a context free grammar, in which we can see that the context sensitive grammars are more powerful, because there are some languages that can be described by context sensitive grammars but not by context free grammars. So there are some languages which can be described by context sensitive grammars but not context free grammars, and context sensitive languages are less powerful than unrestricted grammars. That's why context sensitive grammars are positioned between context free and unrestricted grammars in the Chomsky's hierarchy. So this is also a key point. Try to remember or try to keep this in your mind, that the context free grammars are positioned between the context free and unrestricted grammars, which we have studied in the Chomsky's hierarchy. So this is a diagrammatic representation of the previous concept, in which you can see that the context sensitive grammar is in between unrestricted grammar. Regular expression languages or regular languages are called unrestricted grammars. Okay, those grammars are called regular expression, or regular languages are called unrestricted grammars. And there is a concept which is called context free grammar. This concept, which is called context sensitive grammar, it lies between the context free grammar and the unrestricted grammar. Okay, so context sensitive grammars also have some rules, and it contains 4 tuples such that G stands for the grammar, and summation sign, P and S, where what are those symbols? N is a set of non-terminal symbols, and you know about what are those non-terminals. Summation sign, set of terminal symbols, and S is the start symbol of the production, and P is a finite set of productions. Our rules in P are of the form alpha 1 A alpha 2 implies alpha 1 beta A2. As you can see that alpha and beta are the terminals and non-terminals as well. Okay, and here you can see that alpha 1 and beta and alpha 2. So this is the rule in context sensitive languages. So what are those context sensitive languages? The language that can be defined by context sensitive grammar is called the context sensitive language. And the properties of context sensitive languages are union operation. We have studied this operation when we are studying regular languages or regular expressions. It has intersection property, and it has concatenation of 2 or more context sensitive languages is also a context sensitive. Okay, and complement of a context sensitive language is also a context sensitive. So try to remember these 2 points, that these are the properties in which the union, intersection and concatenation of 2 context sensitive languages is also a context sensitive. And similarly, the complement of a context sensitive language is also a context sensitive. So try to remember these 2 specific rules. The first one is union, intersection and concatenation of 2 CSL is also a context sensitive, and the second bullet is complement of a context sensitive language is also a context sensitive. So these are the specific rules that needs to be followed later on. Consider the following context sensitive grammar. Here you can see that S is a non-terminal and ABC is a terminal, or here you can see that S is a non-terminal, A is a terminal, B is a terminal and C is a terminal, or A is a terminal, capital A is a non-terminal, B is a terminal and C is a terminal. Similarly, we can replace this AB with, the second part, with this AB implies BA. Similarly, we can replace AC. If we encounter AC on the right hand side, we can replace AC with B, capital B, small b, and this is a non-terminal, and these three are the terminals. Okay. Similarly, if we encounter small b and b, we can replace that part with this part. And if we encounter AB, so we can also replace this part with either AA or capital A. So what is the language generated by this grammar? It is a context sensitive language or a context free language. So this is a solution of the context sensitive language. Here you can see that this is the start symbol, and we can replace this AB with this BA. Okay. And similarly, we have seen that we have replaced this AC with this BB. Okay. And similarly, we have replaced this BB, B and B with this. Okay. So these are all the rules that needs to be followed as it is. And the language generated by this grammar is A power n, B power n, C power n, or such that n is greater than or equal to 1. So this is a context sensitive language, and we have used those production rules one by one. I hope you have understood today's lecture. If you have any questions regarding today's lecture, you can email me on my official email and I will apply accordingly. So meet you in your next lecture, inshallah.